Okay, guys, buckle up. We're going to go over some of the things that we were talking about yesterday. You'll see that there's 3 topics up there, and we covered these, and you had homework with 5 questions. So we're going to go over 5 questions, but I'm going to answer some of the questions we had in class, and some of the ones that I think you may have once you've worked with the problem. So try to get to a few of those questions preemptively. So at the top, what we covered so far, we're dealing with exponents, and I really love this section because you get out of the norm and you get kind of into an area of mathematics that you're crossing the threshold, to algebra 1, algebra 2, kind of some of those areas. But you're getting into a spot where you don't have to necessarily follow the rules as long as you understand the subject matter to kind of stay within the ball field. So I'll show you some of those, and how we're going to do that is we're going to solve the problems, but I'm going to show you a couple different ways to solve them. We had a couple people in class that had some great ideas, and I only showed one way to do some of them for today. So let's get into a couple of them, and I'll show you some alternative methods to solving some of these problems. Okay, in the corner, before we get started, I just want to put a couple things up. Remember that we will be following PEMDAS, so order of operations. However, in a couple situations, we're going to do some things that are maybe not in accordance with PEMDAS. Okay, so you have that. And this is just a reminder that anything to the 0 power is 1. And one that we have been and will be using, anything to the negative power can be written as 1 over whatever that was to the positive power. Okay, so those are some pretty key ideas as we go through some of the math problems today. So we're going to go really fast, so I am definitely going to put this onto Google Classroom so that you have that as a resource. Okay, I'm not sure how long this will take, so we may have to break this up into 2 videos. I'm not sure. Okay, so let's look at the first one. Let's go a different color. How about we write our problems in orange here? Okay, so problem number 1 that I gave you guys was 4 to the 7th power, and we have that divided by 4 to the 3rd power. Okay, we're going to do this one pretty much straightforward. So if you look at that, we said when dividing powers, if you have the same base, in this case we do, it's both 4, you can go ahead and subtract the powers. So what this looks like, essentially you're minusing 7 from the 3, so you're left with 4. The top has the most in the way of power, so we leave it as 4 to the 4th. Okay? And if you remember from earlier exponent exercises, that 4 to the 4th power is simply the same thing as 4 times 4 times 4 and times 4. Okay, so if you multiplied those out, you would actually get 256. Okay, so I'm going to put a little box around that one. Okay, so this is the simplified version of this. Okay, so pretty straightforward for the first one. Alright, let's look at the second problem. Okay, we have x to the 3rd power times x to the 5th power. So x to the 3rd power times x to the 5th power. Okay, and this is an example of multiplication of powers. So if they have the same base, in this case we're saying they're x, so we'll say they're the same. That's the same thing as adding the exponents, and so essentially you have x, and then if you add the exponents you have 3 plus 5, and so you end up with x to the 8th. And because we don't know what x is, that's as far as we can go with that one. So that's the simplified version. So let me put a box around that one. Okay, and I do want to try to slow down here just a little bit. I know that some of you will be writing the stuff down, but please do remember it will be on video, so you can go back and watch it when needed. So one thing I will put out there though is that when you're going through this, some of you are going to be saying, wait a minute, you're giving me the answers. And you're right, because we're in the learning phase, and so I'm much less concerned with you getting the exact right answer and marking it right or wrong. I'm much more interested in you becoming comfortable with the process of manipulating these numbers. So we'll have time for the actual yes or no, right or wrong questions later down the road. So, okay, so that's that one. So let's get a little bit more creative now. Okay guys, I'm going to move this up a little bit so we have some more room. Okay. Okay, so starting with problem number 3, we're going to go through some of the alternate ways you can look at it. So the problem was we had 3 to the negative second power, okay, and that to the second power. So what we actually have here is what we call a power to a power, okay? And when you have a power to the power, you can multiply them. So we have a negative, the powers I mean, or the exponents. So we have a negative 2 and a positive 2. So that's the same thing as 3 to the negative fourth power, right? Okay, so following me so far. Now remember that anything to the negative power can be written as 1 over whatever that is to the positive power. Okay, so this is 1 over 3 to the fourth, but now it's positive. Okay, so we have a fraction now. All right, so we're going to take that fraction, and my 4 looks like a 34. Remember, that's an exponent there. So this is the same thing as 1, and let's kind of write it out. 3 to the fourth power is just 3 times 3 times 3 times 3. Okay, so that's what it looks like. And if you multiply everything out, you get 1 over 81. Okay, so I'll just kind of put a box around that. That's the answer we're looking for, and that's the simplified version of this. Okay, so let's look at this a second way. I had, I think it was Nicole might have mentioned something, but she said with the PEMDAS, because we kind of skirted the PEMDAS, didn't we, right? Because you have to do what's inside the parentheses first before you do the exponents. Well, we skirted by that with this rule for powers to powers. So let's go back and look at it doing it the right way, or the PEMDAS way anyway. So let's look at the same problem. So if we have that same problem, 3 to the second power, negative second power to the second power, positive. And if we look at that, okay, let's look at the 3 to the negative second power first. Again, 3 to the negative second power is the same thing as 1 over 3 to the second power. Okay, and then put the second power out here. Okay, so hopefully you're following me so far. All right, and if we go ahead and solve that more or less, we're going to kind of write it out as 1, 3 to the second power is like 3 times 3. Okay, still to the second power, and that becomes 1 over 9 to the second power. Okay, so 1/9 to the second power, well, that's the same thing as 1/9 times 1/9. Okay, 1 times 1 is 1, 9 times 9 is 81. Okay, so that's why I love math, because you can get to the same spot as long as you know what you're doing with multiple methods. So that's what's really cool about this. Alright, so that's number 3. So a couple ways to solve number 3. Alright, so let's go up to number 4. Remember, you need to be making corrections as we go, because I will take this in to take a look at it, but I need you to be able to get it back, and you can use this as notes. Okay, you can hear the phone going off in my background. Kind of ignore that. But okay, let's get to number 4. Okay, so number 4. So we have 3 to the second power, and we're going to multiply that by 3 to the negative third power. Now we said when you're multiplying with the same base, and we do, they're both 3, and we could just go ahead and add the exponents. Okay, well, not a problem. So that's the same thing as 3, and then we have 2 plus a negative 3. Okay, pretty straightforward. So now we're going to have 3, add the exponents, net result is a negative 1. Alright, so remember, 3 to the negative 1 is the same thing as 1 over 3 to the negative 1, or to the positive 1. And remember, that 1's really only up there, it's only useful if it's a 2 above. Just assume that there's a 1 there, so that it's really just 1/3. Okay. So that's number 1. How do you do it? Okay, so let's look at that a little bit differently. Let's go ahead and say, because PEMDAS says exponents first, right? Okay, and we didn't really do exponents first because we did the rule with the powers, so we added them. So let's do the same thing. So let's start off with 3 to the second power times 3 to the negative third power. Okay, so let's take that and look at it for a second. 3 to the second power is the same thing, and I'm going to put these inside parentheses because I'm dealing with each one of these separately. So 3 to the second power is just like 3 times 3. Okay, and we multiply that by the second one, 3 to the negative third power. Remember, that's 1 over 3 to the third power. Okay, so I'm going to rewrite that one more time. The first one, I'm going to go ahead and consolidate that. 3 times 3 is 9. Okay, multiply. This becomes 1 over 3 times 3 times 3. Okay, make my fraction right here. So then we have 9 times, and if you get that all worked out, 3 times 3 is 9. 9 times 3 is 27. Okay, so hopefully I don't confuse you, but I'm going to take this down here and slide over and start over. Okay, so we have more room. So let me rewrite that. We have 9 times 1, 27. And remember, 9 is the same thing as 9 over 1. So really have 9 over 1 times 1 over 27. Okay, I'm going to do a simple way here. Let me go to white because I'm going to cross cancel, because we can cross cancel 9 and put a 1 here, and 9 goes into 27 3 times, right? Okay, so I just did a shortcut here. So 1 times 1 is 1, and 1 times 3 is 3. So you can see that we got the same answer. So we just did it within the boundaries of what PEMDAS says to do. Okay, so it takes a lot longer sometimes to do that, and so that's why these rules with when you multiply powers, or you divide powers, or you do powers of powers, why those rules will kind of help simplify things for you. Okay, but you're more than welcome to play around and do it either way if it makes sense to you that way. Okay, so we have one more. So I got the hand, let's move it up. Okay, so number 5. Okay, number 5, we have 4 to the third power divided by 4 to the sixth power. Okay, so we're going to do it kind of the quick way first. We know that when we're dividing, we can or subtract them, but in this case, we have 4, and then if we subtract the powers, we've got a 3 minus 6. Okay, so that's going to give us 4 to the negative third power. Okay, so we've been here before. So 4 to the negative third power, we'll put that 1 over 4 to the positive third power. Okay, let's simplify it even more. So we have 1, and this is the same thing as 4 times 4 times 4. Okay. Okay, so here we're at this section, and if we multiply that, we get 1 over 64, I believe. 4 to 4, 16, 64, so yeah, 64. Okay, so that's the answer to that one. Okay, let's look at this through another direction. Okay, like I said, so many ways to do these problems. Now, this may be better for some of you who are visual learners. So how about 4 to the third power? We'll put it over again, divided by 4 to the sixth power. Okay, so when you look at that, the 4 to the third power is like the same thing. We just 4 times 4 times 4, right? Okay, everyone with me? So on the bottom, 4 to the sixth power is the same thing. 4 times 4 times 4, only we have 6 of them now, right? Okay, so kind of a funny looking fraction there, but and then we start canceling out, right? So I'll go back to white here so you can kind of see where I'm doing it. So we can cancel these 2 out, and these 2 out, and these 2 out, right? So that leaves you with 1 over 4 times 4 times 4, right? Kind of the same that we saw up here. So 1 over 64. So another way to look at it. So either way, you know, sometimes it's simpler to do one way or the other, but do what's right, what makes sense to you. You know, a lot of problems out there. So much fun to work with these, especially with the latitude that we're going to get with you guys moving on a little bit faster into algebra. all that great stuff. So I'm going to close it out right there. I'm not sure how long this one took, so I'll have to go back and look at my time, decide if I'm going to split it up into 2 videos or not. And that's the homework. So remember, you do turn it in, you will get credit for it, because I want to be able to see what you did. And as you made mistakes, don't bother erasing them, just kind of correct it around it, and that way I can see what you guys were up to. Okay? Alright, we'll get on to a couple new subjects today, but that's going to wrap it up for this video.